Hello there. Welcome to Chapter 9. Here you see these sections. For Chapter 9, I anticipate it's going to take several videos to get through all of this. There's a lot of material in this chapter. And cool thing is, a lot of it is really visual, so I'll try to make that in a way that you can kind of see what it is we're doing as we do the math, and hopefully that'll help you remember it. But all kinds of geometric things such as perimeter, area, circles, volume, angles, triangles, square root. That'll be the trickiest thing that we've seen probably maybe in the whole year, is we have to manage square variables in an equation. But it's not too tough. Hopefully you've seen it before. Before I go any further, you do need to make sure that you have this. If you don't, you'll need to get it. And I'll either have that in class or I will send you some information on how to pick this up. This is actually made by Johnson County Community College. This is the back side of the conversion sheet. So if you have that yellow paper from the conversions, just turn that over. And I'm going to try to get it on my website if I don't have it yet. Hopefully I will by the time we get any further here in Chapter 9. So you'll need that, because the good news is you don't have to memorize all of these formulas like that get a little bit tricky, particularly when you get down in here to like trapezoids and cones and spheres. Those formulas are a little bit strange, so you don't have to memorize those. That's nice. You will have this on the final exam and the test for Chapter 9. So that's good news. Well, let's get into Chapter 9 things then. This is the first slide at the bottom of page 1, and take a minute and look at it. You have a rain gutter to be installed around this office building shown in the figure, and it asks you to find the perimeter. Okay, well, to find the perimeter, what we have to do is we have to add up these numbers, because the perimeter is the distance around, but you'll notice this side is not labeled and this side is not labeled. So we are going to have to figure out, using a little bit of math, what that is. So maybe you can see how we would figure that out. If not, what I would like to do is point out the fact that this side here is 46 and this side down here is 48. Now this is these two sides are parallel here, so if I take this 28 and I slice it off, like imagine this line here just continuing up here, and we slice off that 28, that was 28 here, well then this, I'm sorry, I wrote that wrong. If this one were 28, sorry about that, then that means this distance would match this distance right here. So all we have to do is subtract 46 minus 28 to get that length, and that should come out to be 18 feet. Hopefully you saw that yourself, but if not, that's how you'd find that. And then you do the same thing with this side, subtracting this 68 and this 23. Because again, this 23, this length right here, if we just slice that off right here, we would just see what was left here, which would match this side over here that we're looking for. So if you take 68 minus 23, you get 45. 68 minus 23 is where that came from. Now all we have to do is add up those numbers, and that's where a calculator's for. So punch those in and see if you agree with what I got, which was 228 feet. There you go. So that's the perimeter. It's the distance all the way around that building. And then question number 2 says, well, what if the gutter costs $4.59 per foot? Well, we just found the feet up here. So all we have to do here is multiply that, 228 from question 1 times $4.59 gives me a total of $1,046.52. And there it is right there. Got it? Hopefully you're okay with how we got that question. There. Moving on to page 2. We get into a lot of the geometry you need to kind of be familiar with. We're going to go kind of quick through this because, like I said, you do have the formulas here in front of you that we're going to be looking at. The first one says the area of a rectangle. It says to sketch a picture, so there's probably a traditional looking rectangle right there. If you wanted to find the area of that rectangle, you'd multiply the length times the width. And that formula is right here. If you see my mouse, length times width is right there. also, there's a formula for the perimeter on your sheet. 2 times the length plus 2 times the width, which you can use, or just add up the sides as well. Okay, one of the things when you're finding area, basically what you're doing is you're finding a two-dimensional space. So you're basically trying to figure out, if you were to chop this up into squares, how many squares would it take to fill that rectangle? And the length would be the number of squares. So if you multiply the number of squares this way times the number of squares this way, all right, you would have all of the squares that make up that particular rectangle. And you do that for everything, even if it's a weird shape where the squares don't fit perfectly on it. That's basically what's happening. You're finding a two-dimensional space, and the square is the unit of measure. Okay, now about the square, one thing we know about the square is that they are equal sides. Each of the side lengths are equal. So it is length times width, because really a square is a rectangle, because all the properties for 90-degree angles and opposite parallel sides, four-sided. So when we talk about the square, you can say length times width, but since this length is always the same, you can also write the area this way by taking one side and multiplying it by itself. So we can say that the formula for a square is, for the area is equal to side squared. And that's what's on your yellow sheet there as well. Okay, moving along, a really similar shape that we need to be familiar with is a parallelogram. A parallelogram is a four-sided figure with two pair of parallel sides. Now the difference here is that you don't have to have 90-degree angles like you do on a rectangle and a square. Here's kind of your traditional looking parallelogram right there, and one of the things to notice is that, oh, there's another one, a rectangle and a square, and it wasn't getting labeled, but I thought, oh, that's going to come up on the next slide here. These are three parallelograms. I'll finish my thought there on the next slide here. A rectangle is a parallelogram because it has four sides and there's two pair of parallel sides, but this one is also a parallelogram because it doesn't have to have this one here. This is a parallelogram because the rule of a parallelogram is you don't have to have 90-degree angles. Okay, that's okay for a parallelogram, and that's okay for a parallelogram. It's about the sides, that these two are parallel and these two are parallel as well. Okay, so a square, a rectangle, or this parallelogram is all in the category of parallelogram. Now, what I was trying to say on the other side is to find the area of a parallelogram, we have to identify the base, and the base is one of the sides, and then the height. The key here is that the height is a 90-degree angle from one base to the opposite base. All right, so that has to be a 90-degree angle. That line there represents the height. Now, there's a really interesting property about the parallelogram. Well, you might be thinking, well, that formula, base times height, that's really similar to a rectangle because it's like length times width, but you've got these slanted lines here. Well, I want to show you something here. I'm going to change my pen color because I think this is an interesting way to look at it. I'm going to get blue here. Let's say I took this rectangle, this part of the parallelogram here, and I just cut along the dotted line. Okay, if I cut this off along the dotted line, and then I grabbed it and I moved it right over here, and I drew the same triangle, this is what you would have. You would have a 90-degree angle there, you'd have a 90-degree angle here, and basically you would have this rectangle that is this B times H. That's why the formula is the same. Okay, that's why the area is the same thing. It's as though you cut along that line, you slide it over there, you have a rectangle there in front of you. So that is a parallelogram area. Again, you can find that right here, third one down. There you can see the formula right there for the area of a parallelogram. Okay, moving on to real quick here, a rectangle and a trapezoid. It says sketch a picture of the following formulas, and you can sketch those in your notes right there. Parallelogram. I can't say the words here. Trapezoid is what I meant to say. A trapezoid, it's four sides where you have one set of parallel lines. All right, these two sides are parallel, or these two sides are parallel, but then the other pair is not necessarily parallel. Okay, and these adjacent angles, they both have to be like less than 90 degrees or greater than 90 degrees, the ones next door. You can have a trapezoid with a 90-degree angle like this, but you can only have one. So this right here, if that were 90 degrees, that's okay if you have one set of 90-degree angles there. Okay, I'm a bit over my 10-minute mark here to make it safe that I communicate through YouTube and all that. Okay, so I'm going to stop it here and pick up with video 2 in a moment.